Hi, today we're going to start with another integration technique. That is where I have to integrate trig square functions like sine square A or sine square X, cos square X or whatever the angle is, sine and cos square. I have got a formula for sec square and cosec square, and I have got something for tan square and cot square on my square identities. So on the first page of the formula sheet, you will find these two formulas for sine square and cos square. Sec square and cosec square already form part of my differentiation and integration table. So I do not have an additional formula for that. Tan square and cot square, I will just use the square identities as it is on my first page of the formula sheet. So let's start with an example. If I have to integrate sine square 3x, sine square will become half minus a half cos 2 times whatever this angle is. So I'm going to rewrite this as a half minus a half cos double this angle. So 2 times 3x will give me 6x with reference to x, and this is what I can integrate now to give me the value of sine square integral. So when I have no x's, I will gain a x because this is x0 plus 1 divided by 0 plus 1, and that's how I gain a x minus. Now I've got a half there. I have to see, I must now integrate cos. So when I differentiate cos, it will give me minus sine. But because integration is the opposite of differentiation, so when I integrate, I go from this side back to this side. So I have to go and see where's cos on this side. Cos on this side will just become plus sine. So this will just become the sine of 6x. But because it's more than 1x, I have to divide by the derivative of the angle. And I plus a c. So my final answer will be a half x minus 1 over 12, the sine of 6x plus c. And that would be the answer for my equation. So I go and I see cos will become sine on this side. So when I go to my next one, cos square is a half plus a half, double the angle. So I write it down as a half plus a half cos double the angle. So 2 times 2x will give me 4x dx. And this is now what I have to integrate. If I integrate a half, it will just gain a x. So this is x0 plus 1 divided by 0 plus 1, which will just give me a x. Plus, I have the number in front. Cos will become, cos integrated this way, cos will become the sine of 4x. Remember, the angle can never change, but thereafter I have to divide by the derivative of this angle, which is 4, and I plus a c value. So my final answer will be a half x plus 1 over 8 sine 4x plus c, and that is the integrated value of cos square of the angle of 2x. If I go to my third and my fourth example, when I have to integrate sec square or cosec square, these two are already on the formula sheet, so there is no other identity that you need to use for this. So if I integrate sec square, I must go back to tan. So if I rewrite this, so sec square will just give me the tan of the angle, but because it's more than 1x, I have to divide by the value, the differentiated value of this x, which is 4, and I plus a c, and that will be my final answer to integrate sec square. Even if there's a number in front, like example 4, I have 4 cosec, you just bring down the value of what is there. Cosec square will become, so there's a minus, so if I transfer the minus to this side and make that a plus, so cosec square will become then minus cot. So I will, if you want to put it in bracket, minus the cot x of whatever the angle is, pi x So let me just write it down, pi x the angle like this. And then I have to divide by the derivative of the angle. In this case, if I differentiate pi x, I will just get pi and I plus a constant value. So my final answer is minus 4 over pi, the cot of pi x plus c. You can either write it like this or you could leave the pi at the bottom there. Then that's how you integrate sine square, cos square, sec square, and cosec square. So in the last two, I'm going to integrate tan square and cot square. So tan square, square identity is sec square minus 1, and cot square, square identity is cosec square minus 1. So I can rewrite this into that identity. So I'm first going to rewrite, because there is no tan square or cot square on my formula sheet. So I'm going to rewrite tan square as sec square x minus 1, like this, with reference to dx. Then I can multiply this value in 3 sec square x minus 3. And this is what I'm going to integrate now. So there is a value for sec square. Remember, sec square integrated will become tan. So this will just become 3, the tan of x. It's just 1x, so I don't have to divide by another number. Minus 3x plus c. This will just gain a x because x 0 plus 1 divided by 0 plus 1. And I always add a constant value to integration. And that will be my answer. If I go to a value, the next one, example 6, where I have cot square 3x. Cot square 3x, when I integrate cot square, I'm going to rewrite it down as cosec square minus 1. So I indicate equal, and cot square will become cosec square of the angle minus 1. You can also substitute by u. Later on I'm going to show you how to substitute by u, but we're going to write it like this now. Cosec square has now got a value there. So if I integrate cosec, cosec will become minus cot. So this will become minus the cot of 3x. Remember, the angle can never change, but thereafter I have to divide by the derivative of the angle. Minus, this will just become 1, and this will become plus c, and that will be the answer of integrating tan square and cot square